Good afternoon, ladies and gentlemen, and welcome to the RQ-4 Summer Sunset. I am Staff Sergeant Hunter Kaufman, and I am honored to serve as today's Master of Ceremony for this event. Today's ceremony marks the end of the RQ-4 test program. During its time here at Edwards, the RQ-4 achieved many historic firsts in aviation and set several world records. Initially built as a technology demonstrator, the Global Hawk's clever design helped pioneer the unmanned aircraft environment. In only 25 years, the RQ-4 evolved from prototype to the forerunner of unmanned aviation. Its success led to the development of 10 other variants, most of which have been adopted by allies and sister services. As a service, we would not be where we are without the contributions of this weapon system. But more importantly, our Air Force would not yield such capability without the ingenuity of all who developed and continue to develop the Global Hawk fleet. Today's ceremony is a celebration of achievement, not just of an aircraft, but of a team. We commemorate the RQ-4's many historic achievements, and we honor the work of all members, past and present, who served on this test program. Today, we salute the RQ-4 and its team members and offer our sincere appreciation for their work. A job well done to all of you. I'd like to take this opportunity to welcome our distinguished guest in attendance today, Brigadier General Matthew W. Heiger, Commander, 412th Test Wing. We welcome all Program Office, Northrop Grumman, test, and operations personnel who have traveled here to commemorate this day. Thank you all for attending. At this time, would you please stand for the singing of our national anthem by Miss Kristen Burks.
Oh, say, can you see by the dawn's early light what so proudly we hail at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we watched were so gallantly streaming, and the rocket's red glare, the bombs bursting in air, gave proof through the night that our flag was still there. Oh, say does that star-spangled banner yet wave o'er the land of the free and the home of the brave?
Thank you, Ms. Burks. Ladies and gentlemen, please be seated. At this time, I'd like to introduce you to your host for today's ceremony, Major Mark Drone Johnson, RQ-4 Test Team Lead and Assistant Director of Operations, 452nd Flight Test Squadron.
Thank you, Sergeant Kaufman. Good afternoon, and welcome to the RQ-4 Summer Sunset. I'm pleased you all could join us for this momentous occasion. Thank you to all distinguished visitors for taking time out of your schedules to celebrate with us. Today is a special day. Today we celebrate the heritage of the Air Force RQ-4 test program, and we establish its legacy at Edwards Air Force Base. We take time to remember the many sacrifices that were made and to consider the impact they are making on future test programs. The RQ-4 joins the likes of the X-1, the X-15, and the XB-70 as boundary breakers and record setters. Much like these well-known aircraft, the RQ-4 was indeed an experimental aircraft and one that challenged aviation standards. In its time, the RQ-4 introduced us to new concepts, new capabilities, and new challenges. No longer were pilots constrained by flight duty period or fatigue, nor were aircraft constrained by landing visibility. Instead, new problems arose like satellite time, coordination with intelligence agencies, and pilot availability for long-duration sorties. With several computers in front of them, pilots became pilots, navigators, Air Operations Center liaisons, and more. Even so, RQ-4 aircrew are unrelenting. Such unique challenges were analyzed, overcome, and established as standards within the remotely piloted community. These challenges have become a hallmark of the RQ-4 community, and today is no different. Today, we are more certain than ever of our ability to face these challenges head-on, to adapt, and to succeed. They say that flexibility is the key to air power. With an uncertain future, an undefined environment, and uncommon practices, the RQ-4 aircraft and test team proved that air power is indeed built upon flexibility. The RQ-4 has been the literal example of building an aircraft while flying it. The aircraft's usefulness in all conflicts, past and present, cannot be overstated. Its time here has left an indelible mark on the pages of Edwards history. That is why today, June 9th, 2023, we assemble to honor the success of this program and to commemorate those who took part in its vision. In the words of the late Steve Jobs, if you are working on something that you really care about, you don't have to be pushed. The vision pulls you. Thank you.
Thank you, Major Johnson. At this time, please direct your attention to the screen.
My name is Kirk Harwood. I was the air vehicle lead for the Global Hawk program during the Block 20 envelope expansion. Had very unique aspects to it because obviously the Global Hawk is an automated air vehicle, and so we would plan for missions that were, well, we built up from 4 hours to, I think it ended up being 33-hour mission at the end, and so you had to plan for not only being in the control room for a long period of the day. I don't remember, maybe we settled on 6 hours or something like that, and then shifted people in and out. So you had to have good communication between one team to the next team so that you could get through the whole flight as they got longer and longer.
From my time in the Global Hawk. So I joined the Global Hawk community in 2015, where I started out as a pilot with them, and then proceeded through as a pilot, became an electronic combat officer as well to help us figure out how to be more survivable in SATCOM, either denied or low availability areas as well, and then continued on to operational tests for the RQ-4. The operational perspectives and then also the limitations that the platform had because it was thrust into a national need. It really provided me a perspective as a tester after test pilot school coming into the 452nd about how important it is to bring in your operational context, bring in the experience that you have flying the line, performing missions with the platform, and ensuring that the next level systems or the next level platforms or whatever else comes down the line to the best of your ability ready to do that next mission or that next fight. also anticipating that we're going to be asking those future systems to do things that they were not originally intended to do as well, which is an interesting line to balance. The legacy of the RQ-4 is bringing in autonomy into aviation, into particularly military aviation, bringing in early lessons learned on how in the world do I ask and we'll use whatever words that make sense at the time, maybe a semi-autonomous, whatever we might want to call the RQ-4 definitions are for another conversation, but a platform that has arguably a high degree of autonomy because I don't have necessarily a throttle and stick to interact with that platform, and experimenting and experiencing out in the real world what is required, what is asked for various levels of autonomous platforms. That helped inform, I believe those lessons, those experiences are helping inform future autonomous platforms that are also coming down the line as well.
Global Hawk may be going away. It's done its duty, I guess, but I think there's other things out there, or there will be other things out there in the same vein. They won't be remotely piloted. They'll be autonomous air vehicles. You know, we're hearing a lot about that these days. And Global Hawk and its predecessors actually in Ryan Aeronautical are really the legacy of what we're doing. So all of those older programs and how we've done things in those programs should be very educational for the people coming along doing these newly autonomous air vehicles that we're looking at to go with the next generation of aircraft.
We would now like to welcome Mr. Brad Norman to tell us about the early days of RQ-4 testing and its initial deployment into the theater.
Hello everyone, good afternoon. My name is Brad Norman, and it's my great privilege to speak to you today to remind us all of the early days of the flight test of Global Hawk. I hope to give you a brief little glimpse from one that was there at the beginning of what we went through, how it got started, and some of the results that we came up with. And I have to say, it's great to look out in the crowd and see old faces from those days. It's a great, wonderful privilege to have you here, and I'm glad you were able to come. I joined the industry team for Global Hawk shortly after the contract for Phase 2, as it was called at the time, was awarded. So we're going to dial our calendars back quite a ways to July 1995. And then the airplane didn't even exist yet, so I helped design the airplane, and then joined the flight test program shortly after it stood up in 1996, and I've been flight testing Global Hawks pretty much continuously ever since, and still have, thanks to the program up at NASA, I still have a job. That's great. Not going to be retiring right after I set off the stage here today. So to help give you a glimpse of how this all started, I'm going to just briefly touch on some of the history here. And we'll go back to 1925 in San Diego. And there's a man called T. Claude Ryan, and he had some friends. And he started the first regularly scheduled West Coast airline. So the sense I want to give you during this time is that Ryan was at the forefront of many things that were going on in aviation through the years, starting with like I say, the very first regularly scheduled airline. Los Angeles to San Diego, $14.50 one way, $22.50 if you wanted to come back to LA. Interestingly enough, the field they used, there's no longer an airport there, but if you know where Jesse Owens Park is in LA, if you go from LAX and go up Century Boulevard 7 miles to the east, that's where they were operating out of. And I'm sure that was a pretty rural area at that time. And then they'd fly you right down to San Diego Harbor. You could have a beautiful day, and then come back for the evening flight. Also, Ryan, about this time, decided an airline's nice, but I want to build some airplanes. So they started building mail-carrying airplanes specifically. And then along came probably one of their most famous customers, Charles Lindbergh. So in 1927, you know the story, they converted a Ryan mail plane. And looking at the history, it happened so fast. Lindbergh showed up in San Diego in February 1927, and by the end of May, he was in Paris. Very quickly. And it also will show you the first foray that Ryan had into long-range aviation, right? And single engine. Also during that time, a different company, the aviation historians will remind me that this wasn't all the same corporate umbrella, but it had the Ryan name and it was always T. Claude Ryan behind it. He also designed and produced over 1,000 of the PT-22 trainers that you see on the slide. This was a primary trainer for World War II. Slide, please. Now, post-war, on VJ Day, Ryan had an order for over 1,000 FR-1s, which, if you've heard of that before, it was the first naval aircraft carrier operated with a jet engine. But the jet wasn't good enough to get off the boat, so it had a propeller engine up in front. So the fun trick was they would fly along, shut down the radial engine up front, and then out-accelerate everybody. So that was a Ryan contribution to aviation. It also featured the first laminar airfoil used by the Navy as well. So Ryan was at the forefront of a lot of things. The war ended, and a day or two after the war, all those orders, of course, went away. Later on, 50s and 60s, Ryan was doing a lot of research and was starting to collect little niche programs of building one or two prototypes. Sound familiar? In the vertical lift category, there was the VZ-3 vertiplane on the lower left-hand corner of your slide. Two props, blown flap wing technology that they were trying to demonstrate for the Army and then later NASA. And if you look at the configuration, it was actually a single-engine aircraft. So there was some complexity going on in there to make the two propellers out on the wingspan operate, right? VT-13 Vertijet, very interesting vertical jet program, flown here at Edwards. And the part that I find most fascinating about that one, they built two prototypes and then flew in a very dramatic fashion, with the engine pointed straight down, and it's the only thing keeping you aloft at low altitude for takeoff and landing recovery, if we'll call it that. And out of that test program, both prototypes still exist, no accidents. Well done. Both prototypes are in museums today. XV-5 Vertifan, another Army program, its notable contribution to aviation history, it used a ducted fan to achieve a vertical lift, much like the F-35B today. They also worked a lot of things in the Regala wing became very popular. And they had all kinds of experiments in Regala wing technology of bringing things back from space, bringing boosters that didn't quite make it to space back, bringing capsules. They had a lot of interesting things that never quite worked out, and that was kind of their history during that time, was little things that were interesting but didn't quite work out. Slide, please. They then found a niche. During Vietnam, they started developing UAVs. And they developed quite a portfolio of UAVs that would go out. They were really more RPVs during this time. They weren't quite autonomous. They needed some command and control and a radio guiding beam from a pilot on the ground or in an aircraft. But they developed a huge portfolio of these. Most of them all had one thing in common, is that they didn't use a runway. They were either boost launched off the ground or dropped off a Hercules or something of that nature. Until we get to the one in the lower right-hand corner, the YQM-98A. And that is going to become an interesting airplane for what we have here now. Slide, please. The Compass Cope. So the United States Air Force, we're talking about the early to mid-1970s. The United States Air Force comes up with a program called Compass Cope, and what they want to do is have long duration, high altitude, unmanned flight. So there were actually two companies that built airplanes. There was the Compass Cope Bravo, which was a Boeing program, which was actually the lead of that test program. And then Ryan submitted this design called the Compass Cope R, which they thought, hey, we do UAVs. We'd like to get involved in long endurance flight. How about this? And the Air Force said, great, you can join the program. And they had a little bit of a miniature fly-off. We're proud to say that it first flew here at Edwards Air Force Base. It turns out that all this restricted area around here is wonderful for testing UAVs. Keeps everyone else out, keeps everyone safe. It's a key asset to testing UAVs, as it turns out. So they flew that airplane here. They set a world endurance record for unmanned vehicles at the time of 28 hours plus. And it would actually take us a while in the Global Hawk program to beat that record. It was unlike the previous UAVs. This airplane was operating off of a runway, both for takeoff and for landing. No more parachute recoveries like the previous more tactical UAVs. And it actually had a measure of autonomy. It could actually take off by itself, and it could actually come back and land automatically without pilot intervention when told to come back and land. But the limitation was it was to a very specific runway. They had ground equipment set out on the lake bed, and they could only come and go from a very specific runway direction. It wasn't going to be from any runway you choose. So think about that for a moment too. We need to break that limitation. As it turns out, Boeing actually won the competition. Ryan filed a protest, and then right after that, the Air Force canceled the entire program in 1977. Because that was great, we could make a UAV fly for a long time, but what could it do? And no one really had great answers for that. It didn't have a lot of utility. The Air Force didn't see the need. We needed to wait a while for some other technologies to mature, as often is the case in aviation. Slide, please. So wait 20 years. 1994 comes along, and ARPA, also known as DARPA, but during this time they dropped the D, comes along. And they've realized that some key technologies since we last looked at this concept in the 70s have come along. We now have digital imagery. We don't have to have film aboard the airplane. Like all those other Ryan RPVs were all film-based primarily. So you had to get the airplane back before you could find out what you saw. Digital imagery changed that. You could see it almost real time. But in order to do that, you also had to get the imagery off the aircraft, which required some high-speed, high-bandwidth communications. So satellite technology is developing. We're getting KU band. And the key part is we're getting KU band in a format that could support a small enough antenna that you could reasonably mount on an aircraft. As opposed to an 11-meter dish, you could get one more in the 1.1 meter size, or approximately. That would fit inside a 4-foot wide airplane, and that was key as well. And the other part, unlike Compass Cope, who was stuck on one runway essentially for autonomous flying anyway, was the obvious GPS, right? With GPS, you could navigate worldwide, you could go to any runway you chose as long as you had a mission plan to support it. You didn't need ground-based equipment, really. Okay, differential GPS, we got that, but essentially you could go anywhere. And those were the three things. And the folks at ARPA figured this out and realized now maybe is the time. So they came up with a thing called Tier 2 Plus. And one of the things they wanted to achieve from it, aside from the technology, was this is in the early 90s, right? So we're enjoying the peace dividend from the end of the Cold War. Everyone's trying to save money. UAV programs in the past had kind of gotten over budget. And they're trying to find a new way of defense acquisition to try to cheapen the cost for delivering capability. So they came up with this thing called the ACTD, which is the birds that we first had, the Advanced Concept Technology Demonstration. And so that would award a manufacturer enough money to build 2 prototypes and go fly a little bit, and we'll see the results. There was one big requirement out of all that. The idea was if you went into production after the first few airplanes, you were supposed to be able to deliver the next 10 airplanes or so for $10 million apiece. It's $94, so a little bit changed from now. But $1994, $10 million should give you a ground station to operate it, 10 airplanes, and the payload, and some profit was supposed to be in there too. We'll see how close we got to that as well, but that was the original goal. And then they threw in these slides from the original RFP that ARPA put forward. So for those of you who have always been wondering who came up with these terms, LRE, MCE, those are all from the ARPA paper. We industry didn't drum it up. It came from the government at the very beginning of the program. One other interesting thing to note on there, they came up with the whole concept of the runway requirements they wanted to go to, the sortie time for the loiter in the target area, the climb out, the whole thing. These were the things they wanted. But again, the overarching concern was the $10 million. Interestingly, it's hard to read on the slides. I admit I scanned those from the originals way back when, but it was supposed to operate on a 5,000-foot runway is what they were wanting. I didn't quite achieve that. But we did, we do operate off of a NATO standard 8,000-foot runway. And that was one of the give and takes that government had with the contractor at the time to make that $10 million part work. Slide, please. So Ryan won as the sole award winner for what was called Phase 2 to build 2 airplanes and flight test them. Originally, we were going to fly a total of 21 times. Anyone that's ever had flight instruction from me on the Global Hawk knows about the whole 21 flight speech about why something is the way it is. In May 1995 is when the contract was awarded. And one thing I want to point out from this rollout photo is back in those days, that was shortly again after the peace dividend that I mentioned. And it was after several defense programs were closing down in the local San Diego area, and there was also commercial contracts that were ending. Suddenly, there's this huge glut of laid off, very experienced aerospace engineers, technicians, folks. There were a whole lot of people who got laid off from General Dynamics. There was even a lot of people that had been just previously laid off at Ryan for another program that had closed. So you've got all these very experienced people out there, and Ryan starts hiring them to work on this program. And to me, this is about the same time I came in as a very young guy. To me, that was one of the unwritten hallmarks of the success that the programs had, because we had so many people with so much experience. These guys and ladies really knew what they were doing, and they really put together a program that, yes, it was only supposed to go 21 times perhaps, and that's what we were contracted for originally, but it obviously had huge legs that could continue for quite a long time. So I think that was a key part. All those experienced engineers are laying around looking for work, to be honest. So you see the photo from rollout day, just a note for history for everyone that's seated comfortably. We didn't just wear ties for picture day. We were wearing ties every day. Every day. Ties and slacks, long sleeve shirts, for sure. So times have changed in a few more ways than just that. One personal note about the photograph, if you're really a close-eyed looker, you'll see that there's perhaps 3 people wearing sunglasses. I was one of them. I was in the flight test program at that point, and I thought that was cool. Slide, please. So we've got this autonomous airplane. How are we going to test this? It's going to be unlike any other test program that you've seen. We've done all kinds of testing at Edwards at this point, of course, by the mid-90s, but autonomous? Oh boy, watch out. So we put the airplane together this is the factory in San Diego. We put it together and we ran the engine and we tested as much as we possibly could in a static condition. And then just a shout out to one of the folks that we worked with. This is This is where we invented what I call, at least, the Vance Greenway rule of UAV operations. Top right corner of the slide. Never point the aircraft at your ground station. That's a safety tip. So we did as much as we could there. We disassembled the airplane, trucked it up here to Edwards. It arrived here in August of 1997, put it back together, and around October or so, we started taxi testing. So we first took it out on the lake bed. We laid out chalk lines based on where we thought the airplane should go. And then I don't want to use the term turned her loose, but we put in a test program, and we issued taxi, and we wanted to see what was going to happen. And would it follow the line? Well, of course, the first few times, maybe it just didn't even go. Maybe it only moved forward 10 feet and then declared I'm done. But we worked through all that. And finally, it was time to go fly. During this time to get ready to go fly, we had an interesting problem. How do we test the flying portion? So we tried to simulate as much as we possibly could on the ground and prove to ourselves that this was going to work. And we went through many revisions of flight control software and that sort of thing. And the way we were doing it, this is somewhat old school, but it was cutting edge at the time. We didn't have a lot of software test tools. We had the stuff that we built to actually go fly. So we had a hot bench that was located in San Diego. It replicates the airplane in all the ways electrical possible. And we would connect that via a hard line to the mission control room just over here at Edwards. We'd put the engineers in there for these mission rehearsals. And then we would fly the airplane on the hot bench, and we'd have all the engineers and the test directors be able to react and respond to real live simulated data in the control room. And then it is in the 90s, we would connect the ground control station, the LRE, which is just over there on the other side of the main base runway, we would connect it via dial-up modem. And the pilots that were in there would then be able to send commands to the airplane. And we did several mission rehearsals like this to get ready to go fly. And it was very valuable training. You got to use the actual communication nets that we had in place. You could use the actual radios. It was actually pretty realistic. So to train ourselves for some emergencies, we started having sessions of these rehearsals. We would intentionally inject a fault in the hot bench. And then we'd wait for everyone to go through all the responses and checklist procedures and things like that to, take care of whatever the situation was. And you had to be a little careful on that because the hot bench really wasn't meant as a failure injection point. So if you weren't careful, you could end up with tripping every fault in the book and just having this cascading mess that would not be a valuable training tool. So again, I mentioned I was a very young guy. I was hired as pilot number 3 of a 3-pilot program, and the other guys, had retired from the military at this point and had long careers in flying. And people asked me what I just did, and I said, well, I'm out of college. Here I am. So pilot number 3, somehow, I don't know whose decision this was. I didn't refuse it. I thought it was really cool, but somehow I became the guy that was in charge of coming up with what faults we should inject during these training sessions. And so I would think long and hard about this, okay, what would be really good from a training scenario? What can we reasonably do on the equipment that will be good training for folks to try to find out how to fly this autonomous airplane? And so I came up with a list, and we did these sessions. Well, as luck would have it, by the time we had done about the 4th rehearsal, so far I had recreated during the practice for that flight almost every fault that we were actually experiencing during flight. And so, on the 4th one, when I called before the flight, IMMC failure, which is the main computer, we have 2 of them that runs the computer. I had one of them fail. The team reacted to that. They landed the airplane. And sure enough, the next flight, the IMMC fails on the real airplane. After that, they said, we don't need any more rehearsals. Slide, please. So just like Compass Cope, we had our first flight here at Edwards, of course. It was a great day. We had the envelopes commemorating the event, just like we did, just like Ryan had for their first flight. And that was a really, really big deal. Now, at that time, testing a UAV was nothing like the operation we have now. I mentioned the restricted area. That was very, very important for these first flights, and it still is, of course, today. But at that time, per the safety packages, we had to have sanitized airspace. Nobody else flying around while we let the unmanned beast loose, right? So that restricted us to flying on the weekends only. Believe it or not, when we were taking off and landing, depending on which direction we were going, we would be closing Lancaster Boulevard for everyone's safety, or Mercury Boulevard, depending on which direction we were going. So you knew if Global Hawk was going flying, because they'd run into a road closure if you were there at the wrong time and you didn't know it was coming. So finally the day came along, and we'd been doing, like I say, many, many, many hours of simulations, figuring out the mission plan, figuring out contingencies, figuring out all the various runways that we have here at Edwards. Thanks to the lake bed itself, we had all these things set up. I had 300 hours, as number 3 pilot, I had 300 hours in the sim before we ever first flew. And then the first day, the first flight came on a Saturday, and it was an El Nino year, and you can see in the left-hand bottom photo that all that planning for the runways really kind of went out the window because the lake bed was soaked. I have our team picture up there. That's not exactly from first flight, but just as an example. The teaming arrangement was becoming very, very, very important. We had embedded with us the 31st Test and Evaluation Squadron from ACC. We had a bunch of pilots from them, we had maintainers, and they became a very integral part of our team. And it became a point where we could not function without them. They were excellent. So the teaming arrangement we had during that time was critical to make this success. So by the end of this year, the 1998, by then we'd flown 9 flights, including the first flight of AV2, and as so many firsts in aviation, right before Christmas, we had our first payload flight. Slide, please. Okay, so the pace is quickening. Only 9 flights the previous year. 1999, we increased that to 31 flights during that time, including introducing a new AV, number 3. By this time, we'd left the local Edwards restricted area. We'd gone on several exercises, including a couple of flights all the way to Alaska and back. So with that proven, it was time to go places. And the idea, one of the ideas of this phase of the flight test program was that we would go places and we would demonstrate the military utility of deploying. So Eglin Air Force Base in Florida was chosen for the airplane. We sent the MCE to the sort of outer ring of the DC area in Virginia to be an operationally representative situation of having the MCE not anywhere close to the flying field. And then the pace got crazy. We flew AV-4 for the first time on March 24th of 2000. By Flight 5, we were working up for this deployment, and that's when we broke the old Compass Cope record. Flight 5 of AV-4, 31.5 hours. Setting a new world record right overhead here at Edwards again. The very next flight, we went to Eglin. The very next flight, and this is the amazing part to me about how little this airplane had in numbers of flights. The very next flight from Eglin, we went all the way to Portugal to support a NATO exercise. We went to the coast of Portugal, we imaged it. We took more imagery of some of the islands in the general area and came back all the way to Florida. Could have been maybe a distance record at the time, 31.5 hours. We'll touch on that in a little bit. And then right after that, we flew AV-5 for the first time. Slide, please. Okay, it's 2001. We've got our first EMD order for follow-on airplanes at this point in our hand, and it's time to go put the Global in Global Hawk, right? So we partnered with the Australians, and we did a demonstration. We flew all the way down to Adelaide, South Australia, setting a world record. And I want to touch briefly on this point. There were other opportunities for world records, but in order to have them totally ratified, you have to bring in the FAI, right? And so at this point, I want to credit our leadership at the time. Bob Ettinger, I'm greatly honored to see you here today, sir. Retired Colonel, United States Air Force, Test Pilot School, Deputy Commandant of the base in the past, was our flight test manager at the time. And I don't know if it was your idea, Bob, or not, but I credit you with making it happen for sure. Bob made sure we brought in the FAI, and they watched the flight from both ends and took all the data that was required and that sort of thing to officially certify this flight as the world record distance flight, Edwards, nonstop, unrefueled, to Australia. That took a lot of work and a lot of effort, and I wanted to throw that out for you. If there's any single person that I would point out for the success of this entire program, I would name Mr. Ettinger. We flew 11 flights in Australia. One of the things we were doing was trying to do a concept called cross-cueing, which was taking one sensor, the radar, trying to find targets, and then take that target information and pass it over to the EOIR to take a picture of it. In an exercise called tandem thrust, we found the USS Kitty Hawk, and that's probably one of our most famous payload shots from the program, was finding the carrier up there off the eastern seaboard of Australia. During that deployment, that's also when we passed 1,000 hours of flight time for the program. And again, you see the team there. There's a lot of flight suits in there. There's a lot of other military and the contractor team. Hugely important to have that whole entire team put together to make this happen. It took a lot of people to make the unmanned things work, and it took a lot of people from the various other organizations. Speaking of organizations, this is also during the time where the Global Vigilance CTF was starting to stand up, and then along came the 452nd, of course, right? Slide, please. So post-Australia, we demonstrated that the airplane and the system itself could do what it was designed to do. It had military utility, it was deployable, it was actionable, and it was functional. At this time, not everything goes perfect in the test program. We had 4 aircraft remaining in the fleet after a couple of Class A's. One went on to fly again. We'll talk about that in a moment. And we went on a little bit of a flight test pause after we came back from Australia because the EMD contract had just been written. The airplanes were being worked on, the future airplanes were being worked on to be built, but nothing was existing quite yet. So we were on a little bit of a hiatus. We sent AV-5. AV-5 was the one that went to Australia. It went to Langley for the air show there shortly after Australia in June 2001. In July, we flew once, a little ECS test flight on one of the airplanes. And then we drug out AV-1 again and just did a quick succession of heavyweight landings, 2 flights a day for 2 days and some brake testing. And that was all we were doing. It's pretty slow. And then, "96 days, the reports for the deployment haven't even been written. 96 days after we land from Australia." Slide, please. Everything changed. Global Hawk was called up. The Pentagon knew about us. They knew about our successes. They said, "We want it." And so we put the team together, led by the 452nd, contractors, other help, and that sort of thing. And we all, as a team, went through the mobility line to get deployed. We volunteered, and we got sent forward to go help with all the efforts. And then we got scattered to the winds. Some of us got on C-141s. Some of us got on C-17s. I remember one very dark night where I was boarding a C-141 here on this ramp to get sent forward with a lot of equipment to go help in that effort. And there were many others in this room that went out there too, both contractors and of course military, who were leading us at that time. And we put the program to work. We started doing what it was all designed to do. There was no more test program. There was just real life, real world action. At the end of all that, at least I'm just talking to the first 5 airplanes here. At the end of their work, we brought back AV-3. AV-3 proudly hangs in the United States Air Force Museum at Dayton, Ohio today. After nearly 5,000 hours of flight time, it was a prototype. It's never supposed to fly 5,000 hours. It's a prototype. 195 combat sorties. And at the end of all that, it was the only one to return. Unfortunately, we did lose AV-4 and AV-5 overseas during all that. But we had made a difference that we never expected to do, of course, but we did it proudly. But from those that went forward, I do want to do a tip of the hat and think about the others that were left behind. You know, we could not have done it without the support of the spouses, the wives, the husbands, and the families to go off and go do this. We were gone for quite a long time through these various rotations to austere places oftentimes, both military and contractor, everyone involved. So a tip of the hat to the families for supporting us during all that time while we went to the call of duty. And also during this time, it's been 25 years that we've been flight testing. Obviously, there's been those that have been involved in the program during this time that we've lost. And so perhaps over this weekend, you might think over those that you remember from the program that are no longer with us. They would be very proud to see this day. Because I know there's a lot in the room that are like, wow, 25 years and we're going to stop the program? Who can believe it? Well, when we first started, we never would have dreamed this would go for 25 years. Never at all. Don Murray, I saw you in the room. I remember you told me that you hired on, your contract was for 7 months to do the Phase 2 flight test. I know in my experience, 1998, they told me, Brad, we want you to go to Edwards for 100 days. Well, here we are. And we're not the only ones. There were many, many people like that, and we proudly served. It was the thrill of a lifetime, trust me. I wouldn't trade it at all. Slide, please. So what have we left? What's our legacy? Well, obviously, we still have a great platform that's flying operational sorties today with the United States Air Force, doing great work. We've got follow-ons that have come along. The U.S. Navy is buying the Triton program, and they're going to be putting those to work for their scope. We've delivered a couple small fleets to other partner nations and countries. The NATO bought 5 airplanes. South Korea has some airplanes, and Japan, we're almost ready to deliver the very last airplane for them. And then we look to the future. In the future, I don't want to steal anyone's thunder here, but as the future is coming, the Air Force is talking over 1,000 cooperative aircraft to be flying around the manned aircraft now. And that's a big deal. And I do hope that when the next feller stands up to close down any of those programs, that they include the picture of the Global Hawk as how they got there. Thank you.
Thank you, Mr. Norman. We will now hear from Ms. Jessica Sting Parker about lessons learned from RQ-4 flight test. I apologize, Ms. Peterson.
Awesome, thank you so much. All right, I wanted to talk a little bit, I'm gonna call them lessons applied, lessons that we learned on Global Hawk and we've been applying for the past 25 years. So with that, next slide, please. All right, so you guys have heard a little bit about the history of the first flight of Global Hawk and a little bit about the Block 10 variant. I'm gonna start with the Block 20. So the Block 20 was when, based on the success of the Block 10, the Air Force decided they wanted to have a larger payload and they wanted to expand the wing so that they could get longer endurance on the aircraft. And so that's when myself and Kirk Harwood, who's gonna be talking to you, and many of the people in this room came into play to figure out how do we test this airplane. Now I can't talk without a plane on a stick, so I brought a plane on the stick. And one of the things that we visualized with this airplane is imagine you have a picture, Block 10, and you take one little corner of the airplane and you make it larger. You make everything larger. That's what we did with the Block 20. Well, we learned that not everything scaled the way that you would expect, and we actually lost some stability, some directional stability on the airplane when we did that. And so there was some extensive testing and learning that happened that we had to find in flight test and then apply to the flight controls of the airplane. Slide. All right, so you've heard a little bit about Brad talking about how do we test autonomous aircraft. Well, one of the things that I want people to fully appreciate is this aircraft is not flown with a stick and throttle like many of our normal aircraft. It's flown with a mouse and a keyboard. And so that had a lot of unique things that we had to think about. How do we do flight test techniques on a mouse and keyboard flown airplane? The other thing is the envelope of this aircraft was interesting. So from takeoff to 60,000 feet, so pretty high altitude, and then the weight of the airplane, it would take off at 30,000 pounds, and by the end of a sortie, a day and a half later, the weight would be 15,000 pounds. So it would be half the weight and what it took off. And with that, because it was autonomous, the airspeed that the airplane flew at was based on the fuel, and it would autonomously figure out what speed to fly at. And so all of this gave us unique challenges to figure out where we were going to fly, how we were going to test the airplane. And then the final thing that I learned testing this aircraft is it had a guidance and control mode. So depending on whether it was climbing, descending, cruising, landing, the flight controls would act in different ways based on that mode. And so we had to take all those things into consideration as we tested the aircraft. Slide. All right, so with that, I'll bring up Kirk Harwood, who was my lead at the time, and he'll talk about how we tested the airplane.
Thank you. I'd like to thank the Electronic Warfare Group for bringing the Crow with them today. So, those of us who don't learn from history are doomed to repeat it. And so, first the Earth cooled, and I'll skip a bit. But eventually something crawled out of the ooze and designed the Block 20 envelope expansion program to be 4 flights. A little bit later, the CTF stood up, got with the Ryan and Northrop engineers and sat down and scratched our heads and figured it was going to be at least 10 flights. So we're a little bit behind schedule by the time we got there. And we had more than twice as much work as we thought we had. So we had to think of a different way to do that work. So we chose a model validation approach, and that is where you take the model that's been developed in the wind tunnel and on envelopes and whatnot before that, and compare it to what you get in flight. So we got the 6DOF aero models. We worked with the contractor engineers to marry that up with a MATLAB OFTIS program that has been the legacy at the center here for many, many years. And we used a parameter identification system called Cypher to do maneuvers and derive what the aero model should be compared to what the model said it was. And you can see on the slide that there's some differences between the red dots and the blue dots. I forget which is which, but those should be over the top of each other. So you do the math to figure out how to make them overlay in the model and get an accurate model. So that's what the program we embarked on. Every dot on that chart those charts is a single test point. So there was a lot of test points. Luckily, you can do a lot of test points in 33 hours. So we chose that model validation approach. That's mostly what I described as mostly a post-flight analysis, or at least it was at the time. The other thing you can do is you can do a time history overlay, right? So you can see, drive the model with the aircraft states. You can see if the model's matching what the aircraft is doing in reality. So you can use that real time in the control room, and that's what Jessica and some of the other engineers worked on and eventually got working. So next slide. So when you don't have a stick and rudder, how do you get an aircraft to do flight test techniques? There's two ways to do that. There's what we called engineering commands, and the other one's called ingenuity. The engineering commands were built into the design of the aircraft. They were very limited based on what the engineers believed they wanted to do with an ACTD kind of airplane brought into the Block 20 version. But they weren't rigorously tested. They weren't supposed to be operational. So when they were also operated by hitting the space bar on the keyboard. And so if something inadvertently rested on the keyboard, it would gunshot the command over and over again. So if you wanted 9 degrees side slip, you got 9 plus 9 plus 9 plus 9. Right. So we almost lost an airplane because of that. But so there's things to think about that are not normal when you're flying an automated air vehicle. So that's the engineering commands piece of it. The control surface pulses is an example of that. The other one being the ingenuity, which is my favorite, is an example is bank-to-bank rolls. How do you don't have a stick, you can't put full right stick and then full left stick. You have to tell the airplane to go there, time it with metronome, and say, now go there. And so then you get the bank-to-bank reversal that you need to see to make sure everything's responding as normal. So a list of other maneuvers that we were able to do are listed up there on the slide. The result was we got very limited maneuvers, but it would have been very handy to have gotten insight into that design and design some of that in there to not need as much ingenuity. Next slide, please. So in terms of what we learned, so model validation is the opportunity to fix OFPs very quickly. It's also the opportunity to gain real confidence in the aero control laws and the models. And in my view, every program has to do this. This is a flight science thing. There's no respectable program in my book that doesn't plan to do this. The mission system side of the house needs to figure this out. Late insertion of flight test folks into the program meant that we were playing catch up, and so we didn't get those kinds of things into the design of the software as we would have liked. There was some limited things we could do, but it's an agile manifesto that you design test into your system. So that's one of the things I can see coming in the future. Using this design involvement and the model validation, I think also results in more flexibility and improvements before you get to operational use, right? We were able to fix software before it went to operational use. And so kind of an example of all that is that we initially, before we started, we planned that between envelope expansion flights, we were going to need 4 to 5 days before we did the next flight. Jessica and the team got that down to next day by using this technique. So hugely powerful, and every program should be using this stuff. So Reagan was going to come up here next, but if you can picture anything cooler than Global Hawk, that's what he's doing, so he's off doing that. Instead, Jessica is going to take up his slide. So.
All right, thanks. All right, so next slide, please. So we talk a lot about high altitude, long endurance. Those were the key performance parameters for Global Hawk. That was the decision that was going to be made on whether this aircraft was going to be purchased or not. And so in 2008, there was a request for a demonstration to go out and show that the Global Hawk could meet this key performance parameter. The team was successful. They went up to 60,000 feet, 33.1 hours were demonstrated, and the decision was made to purchase the Block 20s and the Block 30s. Next slide. So I want to talk about some of the lessons learned from this. So the team had done a really great job of collecting data, modeling the aircraft performance, and showing that from a performance model perspective, the aircraft would meet that key performance parameter. But that wasn't enough for the decision makers, those that were going to pay the money, and so there also was a request to go out and demonstrate this in flight. And so in parallel paths, the team did the analysis, and then also a demonstrate flight was done. This was done before envelope expansion had been completed. It also was done before all the sensors had been tested. And so this was a really great example of the team understanding the mission need, optimizing the tests that they were going to do, and doing operational tests while they also were doing performance testing. So kind of a successful demonstration, both from analysis and from flight demonstration. Next slide. Now, one of the big things that we learned from Global Hawk as an autonomous vehicle, so the aircraft was always on condition. And so what that meant is we were able to do data mining, and we didn't have to do very much dedicated performance testing at all. We were able to go and find many points where we were able to use that data. And I'm proud to say that that is becoming more of the standard on many of our programs. It makes us more effective, more efficient, and we can go and get performance data while we're doing other things. So that was a great lesson learned and lesson applied from Global Hawk. Next slide. All right, so Kirk's been stealing my thunder a little bit, but I wanted to talk about another thing that we developed on Global Hawk and now is becoming standard on many of the programs as well. And so back when we were working on the program, we wanted to bring the RQ-4 into the 21st century, and that meant we no longer wanted to have this serial process where you plan, you execute, afterwards you analyze your data, and then you go back and rinse and repeat. And we realized if you're flying an airplane for 33.1 hours, you have some time in the control room that you can be doing your analysis, and if you can be doing that analysis, it's going to make you quicker, and also it might help you identify issues that are happening. And so we developed a tool called the near real-time analysis, and it meant that while we were doing execution, we also were doing the analysis. Next slide, please. And so here, as Kirk had alluded to, originally it took us about 5 days from one flight to the next to clear to the next condition, and we brought a tool into the control room where we can now walk out of the control room with all of our analysis done. The legacy is that Kirk brought this concept over to F-22. Probably many of you have heard of the real-time sim that F-22 has been effectively applying for about the last 4 years, and there's other programs that are doing this as well. So we're very proud that it's kind of the mindset that Global Hawk started, and we're applying to many programs. Next slide. All right, and then the last thing that I want to finish on, so there's many different variants of the Global Hawk out there. I think 10, we're at 10 different variants now, and many of the things that we learned early on have been applied to these variants. So we have our sister service, the Navy, who has the Triton variant that they're flying. There's the Battlefield Airborne Communication Node, BACN, that was an urgent operational need that we executed. We have the NATO Hawk that our foreign military partners have, and then we also have the Block 40 variant that's still flying today. And all of these programs use the analysis tools and the things that we developed early on to test these programs quickly and get them out to the warfighter. And my final slide, so we wanted to talk about, one more slide please. So the legacy. So I've talked about the things that we learned, the platforms that we flew, but really I think the legacy is the people that were on that program. As I look across this room and I look across Edwards, there's many people that started their careers, developed their careers on Global Hawk, and have taken that mindset, that skill set, and that knowledge and applied it to all the different programs that we have here on base. So with that, I'm so happy to see everyone that's here, and thank you to the Global Hawk team for the experiences that we've had.
Thank you both. At this time, we would like to invite our panel of aircrew to join us on stage for discussion about current operations. And I will be one of them.
All right, so I brought some aircrew on stage with us. I've flown with each of these gentlemen up in Grand Forks. We flew together here several years back while we were stationed up there. Now we're all here at Edwards with the 452nd. But they're going to detail you some of the finer aspects of what it's like to fly operationally. So take your mind away from Edwards for a minute. Think of Grand Forks and what it would be like to fly day to day in support of any combatant command, CENTCOM, NORTHCOM, AFRICOM, any of those. So, gentlemen, can you tell us briefly in your own words, what is the mission of the RQ-4? Specifically, right now, we've got the Block 40 still flying. Tell us a little bit about what it does, some of the specifics of that.
All right, I'll take this one. So Block 40 and RQ-4 right now is an ISR platform, so intelligence, surveillance, and reconnaissance. So our goal, I like to think of the Global Hawk as more of a painter. Our job is to go out there, find the information, and paint a picture for all of our allies, all of our customers, and give them the best tools they can to go and do a further mission. We don't carry weapons on the Global Hawk. We're strictly to do that reconnaissance mission. So that's how I always viewed it, as the painter of the battle space, so that our allies and friends can get the job done.
Okay, thank you. So Sting was up here just describing some of the other variants that we have. We have about 10 variants, I think it is. Some of the more recent ones that we've employed in theater, the Block 20 and the Block 30. Can you differentiate those from the Block 40 and what it does, and tell us about them?
Yes, I can help answer that one. So the Block 20 was that Bacon node that Jessica mentioned. Block 30 had an EOIR camera and ASIP on it, and that could get imagery and also get signals intelligence to the battle space. For the Block 40, we have a SAR and movement target indicator radar on it. So we're able to look at a giant area and see all the movement within that area and then report back to possibly the other assets. We did that multiple times throughout operations, where we would find movement in this one area and then pass it to our sister squadron at the 12th and have them go shoot the imagery to actually see what it is.
And the 12th, where's that located?
Beale Air Force. It was located at Beale Air Force Base.
Okay, so North Dakota and California, for all those who don't know. Could one of you, Phoenix or Matt, could you tell me a little bit about the various mission sets and how the RQ-4 really excelled in them? A little bit about like NORTHCOM, SOUTHCOM versus CENTCOM sort of stuff, maybe current EUCOM stuff.
Sure, I can answer that one a little bit. So Global Hawk, obviously flying it via satellite, right? So the planes are in Guam, in the Middle East, and then CONUS as well, and then in Sigonella. So truly global, right? So I, for one, flew a lot of PACOM missions. So those missions were obviously going to places near where so you can all look at a map and probably guess where those went. But basically, scud hunting, looking for big convoys, that kind of stuff, right? So the Block 40 sitting over there, that kind of mission set has a very particular target that they're looking for, all things moving on the ground, right? It doesn't have a camera, right? Whereas the Block 30, so it could also be used in PACOM, EUCOM, so doing SIGINT missions, signals intelligence gathering, a lot of the AFRICOM stuff. I think that got turned off a few years ago, but they're in Ukraine, right? So Black Sea stuff, you can see that on FlightAware, unfortunately. But that's all there. NORTHCOM, SOUTHCOM, I know those were big missions, so I'm sort of removed from it for a few years now, but those are always exciting. I know the Fukushima reactor was a big tasking that came down. Block 30 got tasked to go take IR imagery, I believe, right, of the overheating Japanese reactor, so to go check on that. So it's fun to be a part of real world.
That was following a tsunami, right? And
yeah,
the reactors were overheating?
Yeah.
Yeah. So basically, it was just supporting every combatant command on a daily basis. I think it was when, back 2017, 2018 timeframe when we were in Grand Forks, I think we had, was it 5 of the COCOMs taken care of out of 6 at a time? I think Beale was operating in all 6 of them. So, yeah, quite widespread, and aptly named the Global Hawk. So, couple more questions. Could you tell us a little bit about what it was like to a shift that you normally come in, so working 4 or 5 days a week? What was it like to come in on shift, fly, office work, that sort of thing? What did that look like? Can you tell everybody that?
All right, so basically, we worked a standard. When I first got there, we worked what was called a 4-3. So you did 4 op shifts, then you had 3 days off. As our manning dwindled due to other programs coming online, we were losing manning. We shifted to what they called a 4-1-2. So you would do 4 days on, 11-hour shifts in ops. Then you would do a 1-hour office day, and then you would get 2 days off. There's no holidays, there's no weekends. It's night shift, day shift, swing shift, whatever you need to get the mission done. We would be driving in blizzards to meet local training requirements or ATO missions on the daily. We eventually did cut back a little bit to about 10-hour shifts, but generally you could expect to come in anywhere at 10 o'clock at night, and you'd be probably leaving around 9 a.m., assuming you didn't have office duties the next day.
Thank you.
I could say one of the most unique experiences of doing shift work, specifically at Grand Forks, just because of the latitude. You'd come in and there'd be no sunlight. It's dark out. You'd spend your whole night in a box, and then you'd leave, and it was still dark out, and you'd try to figure out how that happened. So that was definitely a unique experience of working night and swing shift at Grand Forks. There was some very unique daylight times.
I echo that comment. Two more questions, gentlemen. So first, what do you think is the most misunderstood thing about the RQ-4?
I think a big misunderstood thing is that the people here in the US, we're the ones operating and doing the mission. And that, like, when other aircraft go and deploy, that's when they're doing the mission. When they're home, they're doing training and getting current on stuff. The RQ-4 doesn't really get that opportunity as much as the other aircraft do. We go to work and we're actually flying sorties that are required by the COCOM commanders in order to satisfy their requirements. So it's nonstop basically, where we started to use a term called deployed in garrison, because that's essentially what we were. We had to limit our office work to try to get the mission done. I think that's a big misunderstood thing that people just don't really realize. That's quite different from every other manned asset.
So you think in some ways it affected your work-life balance a little bit?
Yeah.
Yeah. Ditto.
Small thing too, so all the talk about like autonomy and things like that, yes, that's true, and it's an unmanned aircraft, but it's a very manning-intensive unmanned aircraft, right? So let's not forget, the L3, the Raytheon, the Northrop, all the contract, the back end, the servers, the antenna, all the comm system that goes into keeping this plane the maintenance side, right? So yes, there's a pilot and sensor operator sitting next to each other. Oh, 2 people, right? Well, it also took like 24 hours worth of planning and like X many people on the ground who actually had to launch the plane and make sure all the connections and ports are open and all that stuff. So,
yeah, don't forget the mission planners either.
Right.
Yeah. So, final question, any of you can answer. What is your most memorable or proudest moment flying the RQ-4 operationally?
So I was deployed to Al Dhafra Air Base in 2019 and 2021. And in my second deployment, we actually had an RQ-4. I was the op soup on shift, and the mission control element out in Grand Forks sends me a message saying, hey, aircraft is approximately 3 hours out, just hitting a particular airspace route to get through another country that hates us. And so we have an Excel sheet that we type in. It tells us roughly duration of flight, fuel burn, things of that nature. And basically, the flight had said, okay, this is going to be a 29-hour flight. This aircraft had already been deployed for around 10 years continuously. They didn't rotate like back to the stateside for depot maintenance or any heavy inspection or phase. So the aircraft wasn't capable of flying 29 hours anymore. I had just talked to maintenance the day prior, and they had come in and told me, like, hey, why'd you bring us a jetback that was, basically at dry weight? It was at 500 pounds of fuel, which for us is basically unusable. So I said, oh, well, that's weird. We'll look into that. Well, that's the plane that's flying, and that's the plane that just called in and said they have 3 hours until they come back and should be arriving minimum fuel. So we made our plan, came up with a game plan to get the aircraft inbound on the runway, told them, hey, you're going to take the aircraft, declare min fuel, land the aircraft, accept no holds. We did end up taking one turn and holding for a C-17. The aircraft lands, and as the aircraft is on the flare to landing, the pilot who's flying it gets a fault saying, hey, the aircraft has 50 pounds of fuel on board. Like, okay, That's not great. We don't know what'll happen because it's never happened before. So it touches down, and I had already stressed to tower that we can't delay. So they tell us to hold position on the runway. They wanted to taxi some unusual planes past us. And when they tell us to continue, the pilot sends a command for the aircraft to continue taxi. And from his words, he just lost the plane. I don't know what it looked like. From my perspective, within 15 feet of the plane, is it surged forward about 5 feet and then shut off. And basically it had hit fuel starvation. So we were within about 3 minutes of fuel starvation while we were in our holding pattern about 5 miles away from the base. So we did save that aircraft. It was a Block 20 Bacon, which is now sitting at Grand Forks for hypersonic testing.
So can you explain to them why you would drive it to fly that long and really press so close to fuel starvation like that?
So at the time, this was during Allies Refuge. We were the only actual radio set in Afghanistan at the time for the Bacon. So if an aircraft was flying through Afghanistan talking to someone during the drawdown or during NEO operations to get everyone out, you were talking to an RQ-4. It was the only radio that existed. All the radios had already been taken down at that time. So we were directed to fly to bingo fuel, or minimum fuel, to make it back to base every mission for about 3 weeks.
Thank you. Anyone else?
I could talk to, so my probably favorite experience, and this was a younger lieutenant, and I had the privilege of going to be an LNO, or a liaison officer, in UCOM, and I've been there for about a month. Again, younger lieutenant, trying to get my bearings in an AOC, which had a lot of people with much higher rank than lieutenant. And we had gotten to a meeting at one point, and they were talking about we need this particular resource. And everyone in the room was kind of silent. They couldn't figure out exactly what they needed. And I'm over here going, I'm pretty sure the RQ-4 can do that. But everyone in this room is very high rank, and I don't want to say anything until the captain next to me nudged me, and I kind of did the scared lieutenant. We can do that. That was the coolest conversation that followed. It wasn't a who are you, it was what do you have, what can you do it, how can that platform help us? And for me, being able to explain that and bring that RQ-4 into a bigger picture, that was probably the coolest opportunity I've had in the RQ-4.
Thank you.
At this time, we would like to invite Brigadier General Higer to the stage for a special presentation from our host. To commemorate this ceremony, the RQ-4, and the remarkable achievements of the RQ-4 test team, Major Johnson will present Brigadier General Higer with 2 gifts on behalf of the Air Force Flight Test Museum. The first gift is a section of an RQ-4 wing. This particular wing was involved in ice-shaped testing in 2016. To date, RQ-4 pilots are prohibited from flying through areas of known icing. This greatly affects RQ-4 operations at home and abroad. For instance, in 2013, the RQ-4 unit at Grand Forks Air Force Base reported that 51% of sorties were affected by icing. And to help characterize this issue, the RQ-4 test team took an unprecedented approach to testing. They 3D modeled, replicated light icing conditions, and then glued them onto the aircraft for testing. The results of that test changed the flight characteristics of the RQ-4. The results are still being used today to inform icing restrictions within the flight manual and to establish new anti-icing capabilities.
So, sir, this was a really unique piece of test history right here. As I understand it, what I was told by some of my pilots is it's the first time that they can recall replicating icing conditions, gluing them onto a wing, and then flying, versus the traditional approach where you fly behind a tanker and get sprayed with water, which is not really something that we can do with the Global Hawk. But very significant piece of test history, sir, and I hope you'll display it proudly in the museum.
The second gift is a plaque dedicated to the RQ-4 test team. The inscription on the plaque reads, "Carrying the Fire." The phrase was inspired by Michael Collins' 1974 autobiography. Collins was an Air Force test pilot at Edwards Air Force Base and a graduate of the renowned Test Pilot School. Later, he was an astronaut involved in Projects Gemini and Apollo. On July 20th, 1969, Collins piloted the command module during Buzz Aldrin and Neil Armstrong's descent to the lunar surface. It was in this moment that Collins reflected on the significance of his part of the mission. With Collins' help, the Apollo astronauts and control room explored the unexplored, documented their findings, and established new norms for going forward. The RQ-4's journey has been no different. We established new norms within the remotely piloted community. We redefined the baseline for unmanned aviation. Collectively, our contributions will last for generations. Michael Collins returned home to pass the torch to future astronauts. The RQ-4 and its team now passes the torch to successors, ready and willing to push beyond the unknown.
So, sir, what you have here is a dedication to the jet itself. This piece, also for the museum, is a dedication to the team, and it reads, "Dedicated to the men and women of the Air Force RQ-4 test team who ascended new heights, established new norms, and traversed the unknown. 9 June 23." And sir, if you like, the floor is yours.
Captive audience, Mike, Friday afternoon, going to be another 30 to 40 minutes. To everyone who had a hand in making this happen, not the least of which is the leader, the project officer drone, thank you very much. These events do not just happen, and they take a lot more work. Well done, and let's give them all another round of applause. So many thoughts, so many stories that I could tell and springboard off of what you've already heard today. I will not do that. Rather, I'll say, save it for the next time you see one of us, one of the folks that are on this installation, and ask us on a one-on-one or a one-on-two scenario, what's your memory of Global Hawk? What's your memory of RPAs? I don't believe the U unmanned in these vehicles, by the way. I believe they're remotely, not un, as you mentioned so well. I'm going to give two quick vignettes. They're separated by 15 years. The latter of those was when I was the commandant down the street at a little school that way. I go to Korea in spring of 2018, and the Korean, I'm a colonel at the time, the Korean 06 that's shepherding us around the base is very, 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 very infinitely number of varies proud of this gigantic facility that they're assembling. And I said, what's going on in there? And he looked at me and he said, I can't tell you, but it may rhyme with hawk. The rest of the story you have here right now. So here we are 5 years later. They were exceptionally willing, exceptionally enthusiastic partners, and this platform and all the folks that have enabled its success for the last 2+ decades really drive home partnership in a way that a lot of folks that fly or operate manned air vehicles don't appreciate or don't understand. So you have a large thing to be proud of in the connections that you have with our international partners, not the least of which is South Korea and the ROCAF. Go back another 15 years, literally 20 years ago right now, I was a student at test pilot school. I don't remember if I was flying with an instructor that day or not. Let's assume I was, and therefore my call sign was Cobra something. And I'll say Cobra 13, I'm on my way back in a T-38 or F-16. And here's something else that you've done that didn't get talked about a lot today. This vehicle specifically, and you have driven changes in culture. Changes in culture in air traffic control, in the FAA and the Department of Transportation, in the public, accepting that they are in airspace with something this big that flies that high. That was not around 25 years ago. And so here's my vignette as I get off the stage and hand this to Drone. So think about how far we have traversed. And here's my vignette. In 2003, I'm on my recovery back into Edwards, and I check in with Sport, got the field in sight, I want to set up for X, Y, and Z, call it initial. And they say, the only traffic between you and Edwards is a Global Hawk, call it in sight. And I say, Global Hawk in sight. And then the Sport controller said to the pilot operating the Global Hawk, Hawk 1, report the T-38 in sight. All right, and with that as the vignette of how far we've traversed as a society and all of those that live in the air and enjoy it. Thank you all for being here. Have a great weekend, and I could not be more proud of you, Drone, and what the team has done here. Thanks for being here, folks.
Thank you, Brigadier General Heiger. In keeping with the Air Force tradition, we'll conclude today's ceremony with the playing of the Air Force song. We invite all of our guests to join us in standing for the Air Force song.